Alright, we are going to get started on chapter 7.2, which is parabolas. And so there are a couple of things I want you to know about parabolas. There are two types that we're dealing with. There's the y equals parabola, and then there's the x equals parabola. They're very different in a couple of different ways here. But let's go ahead and figure out everything that we need to know about these parabolas here. The vertex of each parabola is h comma k. Now, despite the fact that this is regular old h, in class there was a little bit of confusion over what h actually was. And the reason why I labeled it opposite in class was because I want you guys to have the idea that anything happening inside the parentheses is opposite your intuition. And we'll do several examples of this so that you guys know what I mean by opposite intuition. The vertex on the x equals parabola is the same thing. It's h comma k. The only difference is that notice how h is on the outside and k is on the inside. To find the focal distance of the parabola, we use c, like we always have, like for the ellipse and for the hyperbola, except we're going to use the absolute value of 1 over 4a. Now that's going to give us the distance, right? And distance being always positive, we are going to use the absolute value of 1 over 4a. Where these two types of parabolas part ways is how they open up. In the y equals parabola, you guys have seen this before. It's going to be an upward facing or a downward facing parabola. Now, what determines whether it's upward or downward facing? It all depends on whether or not the a term is positive or the a term is negative. On the x equals parabola, it will either be facing side to side, and it's not like a hyperbola where it's going to be both, it's going to be one or the other. And that again depends on whether or not a is negative, it will be facing to the left, or if a is positive, it's facing to the right. Another thing I want you to notice when we're finding focal distance is that this a and this a are the same. Right? This a and this a are the same. Alright, so without further ado, let's go ahead and graph a couple of these. That way we can get used to seeing how this looks. I'm going to give you guys example 1 here. This is -2 parentheses x minus 4 equals the quantity y minus 1 squared. Now when dealing with a parabola, you always want to ask yourself first, which one of these things is being squared? Y is being squared, which means we need to get x by itself. I'm going to go ahead and divide by -2 on both sides. I get x minus 4 equals, well, y minus 1 quantity squared divided by 2 is the same thing as -1/2 times y minus 1 squared. And now I'm going to add 4 to both sides. So I get x equals -1/2 times y minus 1 quantity squared plus 4. And now from here I have enough information to get myself at least started on this process. What I want to do is I want to label the direction of the opening, I want to identify the vertex, and I want to identify the focal distance, which is c. Well, the direction of the opening, this is an x equals parabola that is negative, which means that I am going to have a leftward facing parabola. The vertex is 4, 1, remember, with your intuition, opposite your intuition inside parentheses. And c is going to equal the absolute value of 1 over 4. A in this case is -1/2. And in this case, that's going to give me -2. So the absolute value of -1/2 is 1/2. So from here, we have enough information to graph this parabola. Okay, sorry, I have no idea why the program just bugged out like that. Anyway, I'm going to go to my vertex, which is 4, 1, 1, 2, 3, 4, up 1. This is a leftward facing parabola, so it's going to do this. I'm not really too crazy about the length and the width and whatnot. As long as I have a leftward facing parabola, I'm okay. So what I'm going to do now is I'm going to draw my focus, and then I'm going to draw another part of this parabola that I need to show you guys. The focus is going to be 1/2, and think back to all the other conic sections we've dealt with. Every time we've dealt with a focus or foci and a hyperbola or an ellipse, it's always been inside the graph. And so from here, if I'm going to move half a step and stay inside the graph to draw the focus, I need to move half a step inside. And don't pay much attention to the drawing because it looks like I moved one full step, but that's because of the graphical accuracy. Right? And then I'm going to draw another line. This other line is going to be the same distance, and yet it's going to be on the outside of the parabola. This line is called the directrix, and I'm going to go ahead and draw that here. 1/2 step outside the parabola. And so what I need to do now is I need to find my focal coordinates. My focal coordinates are my vertex minus, this time because I'm moving left, vertex minus my focal distance. So it's going to be 4 minus 1/2, comma 1. Or, to make it simplified, you could say 3.5, comma 1. And my directrix is a line. And it's a vertical line, which means it's going to be x equals a number. Well, I had to add a half to get to my directrix, so it's going to be 4 plus 1/2, or 4.5. All right, I understand that's confusing. We will do several more examples right now. Okay, let's start number 2 here. We have to ask ourselves which of these terms is being squared. Obviously, it's x squared, so we're going to get y by itself. I'm going to multiply both sides by 2, so I end up with y minus 1 equals 2 parentheses x minus 8 squared. And I'm going to add 1 to both sides, so I end up with y equals 2 parentheses x minus 8 quantity squared plus 1. So from here I'm going to identify the direction of the opening, the vertex, and the focal distance, which is c. The direction of the opening, this is a y equals parabola, and it's positive, so it's going to look kind of like that. My vertex is going to be 8, comma 1. Remember, opposite your intuition with your intuition. Now c is going to be 1 over 4a, and that is 1 over 8. So let's go ahead and graph this and see what it turns out to be. Alright, so I'm going to go to my vertex, which is 8, comma 1, so 1, 2, 3, 4, 5, 6, 7, 8, 1. I know it's going to open up upwards. And again, now we have to use some common sense. Our focal distance is 1/8. It has to stay inside the parabola. So the only way I can move and still stay inside the parabola is up. So I'm going to move up 1/8, and I'm going to go ahead and draw my circle. My directrix is going to be 1/8 of a step lower. And it has to be on the outside of the parabola. So that is the line for my directrix. So, if we're going to find the focal coordinates, we have to be smart. We have to use common sense. Which of these coordinates is impacted by the focal distance? Well, since I had to move up, it's going to be y. So it's going to be 8, comma 1 and 1/8. Remember, I had to move up to get to the focus. The directrix is going to be a horizontal line, which is a y equals number, and that's going to be the y coordinate of the vertex, so 1 minus 1/8, which is 7 over 8. Alright? Alright, example 3. I'm going to up it a notch. We have a parabola written in standard form. We need to get it into vertex form. And how do we get all conics into their vertex forms? We use completing the square. So it's going to be x equals y squared minus 14y. I'm going to leave myself some space. Plus 52. I'm going to add inside the box. On the outside, I'm going to subtract the box. I get a negative 7 on the insides of the box, so therefore x equals y minus 7 squared. This is 49, so 52 minus 49 is positive 3. So this is our equation for the parabola. So from here I'm going to identify the direction of the opening, the vertex, and the focal distance. The direction of the opening, this is an x equals parabola, and it's positive, which means it's moving to the right. The vertex is 3, comma 7. And the focal distance is going to be 1 over 4. A in this case is 1, so it's going to be 1 over 4. Let's go ahead and graph this. I'm going to go to 3, 7. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. It's a right ways opening parabola. My distance is going to be 1/4. The focus needs to be inside, so I'm going to move to the right 1/4 as best I can. The directrix needs to be outside, so I'm going to draw my vertical line outside 1/4 of a unit away. Again, the drawing isn't necessarily super important as long as you get the details correct. The focal coordinates, because I moved along the x-axis, it's going to be 3 plus 1/4, or 3 1/4, comma 7. The directrix is going to be 3 minus 1/4, or 2 3/4. Oops, wrong thing. It's going to be x equals 2 3/4. And you're done. Okay. I kind of forgot what number we're on. I had to go do some laundry for a second. But anyway, it doesn't matter what number we're on. We have to complete the square for this one. So I'm going to say 3x equals y squared plus 6y, parentheses, leave myself some space, plus 12. I'm going to add the box. And on the outside of the parentheses, in order to balance out, I'm going to subtract the box. Inside the box goes 3. So I'm going to get 3x equals y plus 3 quantity squared. This is a 9, and that's plus 3. Now I'm going to go ahead and divide everything by 3. So what I get is x equals 1/3 y plus 3 squared plus 1. So now I'm ready to graph this parabola, or at least find out all the information that I need to know before I graph it. Direction of the opening, this is an x equals y squared parabola, and it's positive, which means it's facing right. The vertex is going to be 1, -3, because it's opposite your intuition on the inside of the parentheses. And to find c, we're going to use 1/4a. In this case, that is 1/4 which is 3/4. So let's graph this thing. Let's change colors here. Okay, so my vertex is 1, -3, so I'm over 1, 1, 2, 3 down. It's a right side facing parabola, so that's what it's going to look like. My focus, remember, it needs to be inside the parabola, so this 3/4 distance is going to be to the right 3/4. The directrix is going to be outside the parabola. It has to be. So it's going to be 3/4 of a unit outside the parabola. So let's figure out our focal coordinates. Our focal coordinates, they impact the x-coordinate, so it's going to be 1 plus 3/4 because we move to the right 3/4. So that's going to be 1 3/4, comma, -3. My directrix, remember it's always in the form of an equation. A vertical line is x equals a number. 1 minus 3/4 is x equals 1/4. And there you are. You are done with that problem. Let's move on to a different style of parabola problem. Alright, the next thing you might be required to do, or rather you will be required to do, is to write the equation of a parabola given some sort of information. And so let's go ahead and get some information and we'll see how it goes. If I told you that the vertex of the parabola was at 0, 1 and that the focus was at 0, 5, the first thing you need to do, you have to do in order to get this correct, is you have to just sketch a picture of what you're being described. And that can be a picture as easy as this. 0, 1 is my vertex, and then 2, 3, 4, 5. This is my focus right here. So now I want you to think, in what way can this parabola open and maintain the focus on the inside? Well, it's certainly not going to open up that way. It's certainly not going to open up downward. It has to be an upward-facing parabola. So I know it's going to be some sort of y equals positive x squared. And since the focus is at, since the vertex is at 0, 1, it's really x squared plus 1. There's no horizontal shiftage, so there's no like x minus 3 squared plus 1, right? There's no horizontal, a shifting going on. So it's going to be some form of y equals x squared plus 1. Now the problem is that there used to always be this kind of a hanging out here, right? In all of the forms, remember this y equals a parentheses x minus h squared plus k? There's always this a hanging out. So we don't know what the value of that a is. But there's a way we can find out. And that has to do with the focus. The distance between the vertex and the focus, we can just count it out. It's 1, 2, 3, 4. So if the distance between the vertex and the focus is 4, that means that C equals 4. Now, C was used to find the focal distance. That was C equals 1 over 4A. Well, in this case, if we already know C and we're trying to solve for A, I'm going to take this 4 and plug it into C. So I end up getting 4 equals 1 over 4A. I'm going to multiply both sides by A. So I get 4A equals 1/4. And now I'm going to divide by 4. And what I get is A equals 1 over 16. And that is going to move straight into here. So I get 1 over 16 x squared plus 1. And I have my box. Okay, that can get a little cumbersome. Let's do a couple more because I understand that can be kind of crazy. Okay, let's try another one. Let's go vertex 8, 6, and the focus is 2, 6. Well, just for a little bit of accuracy's sake, I'm going to go ahead and just paste this thing in here. And I'm going to first, again, you just draw a sketch of the graph. 8, 6 is 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. That's right there. And the focus is 2, 6. So it's going to be 1, 2. And then the same elevation. Here's the focus. So, use some sense. What is the only way this parabola can open up and maintain the focus inside? It has to open up left. So I know this is going to be some sort of x equals y squared parabola. That's good. From here, I'm going to figure out the distance between my focus and my vertex. So that is 1, 2, 3, 4, 5, 6. So C equals 6. So let's go ahead and figure out what A is. C is going to equal, whoops, not C. In this case, C is 6. So 6 equals 1 over 4A. I'm going to multiply both sides by A, so I get 6A equals 1 over 4. Divide by 6, so A equals 1 over 24. Box that. I now have all the information that I need to write the equation of this parabola. It's going to be x equals A. In this case, A is 1 over 24. Y minus 6, because it's opposite your intuition, quantity squared, plus 8 because it's with your intuition. All right? Let's do one last one where they throw you a little bit of a curveball again. Now they give you focus is -4, -2, and the directrix is x equals -8. Okay, so let's draw this thing out. Focus is at -4, -2, so that is -1, 2, 3, 4, -1, 2. That's the focus right there. And the directrix is x equals -8, so that's -4, 5, 6, 7, 8. And I'm going to go ahead and just draw my directrix here. Well, remember, the vertex of the parabola is always halfway in between the focus and the directrix. So let's go ahead and count how many spaces there are between the focus and the directrix. There are 1, 2, 3, 4 spaces. So 4 cut it in half is 2. So I'm going to go 1, 2. My vertex must be in the center. And in order for it to not cross the directrix and stay inside with the focus, it has to be a right-facing parabola. So my distance between my vertex and my focus is 2. So let's figure out what A is. 2 equals 1 over 4A. a equals 1 over 8. Did a little bit of math in my head right there. So now I have all the information I need to write out. Actually, I'm sorry. The vertex. This is negative 1, 2, 3, 4, 5, 6. Negative 6, comma, negative 2. Now I have all the information that I need. I just counted out. That's how I was able to find the vertex. So now I'm going to get x equals 1/8 y plus 2, opposite your intuition, squared minus 6. And that's as far as you need to go. Okay, so I hope I haven't thoroughly melted your brain, but hopefully you'll come in with some questions tomorrow, and we'll see you.